Hello, everyone. Welcome back. We are covering geometric sequences in this video. Um, I am going to break it up into two parts. This one, we will just go over the sequences, and then in part two, we will go over partial sums and infinite sums. Okay, so take notes. 8.3 Geometric sequences. All right, so we looked at what an arithmetic sequence is. It's when you have a number and then you keep adding like 5, and you keep adding 5, and you add 5, and you add 5, okay, to get the next one, to get the next one. Okay, with geometric sequences, so this here is a sequence of the form A, and then you take that first term A, you multiply it by R, some R, and then to get the next one, you multiply it by R, and to get the next one, you multiply by R, and you keep on going. You keep multiplying by R, multiplying by R, multiplying by R. Okay, so the number A is the first term. Is the first term. R is what we call the common ratio. Okay, so it's the common ratio, which is the ratio between two consecutive terms. Okay, and the nth term is given by the following. An equals A. Again, A represents the first term. R is the common ratio to the n minus 1. Okay, so this is our nth term formula. Okay, let me talk a little bit more about the common ratio R. Common ratio R. So this is the ratio between any two consecutive terms in the sequence. So just like division, just like subtraction is not commutative, the order matters here. Okay, because we are going to be looking at division or the ratio. And so we would take one term and divide it by the term before it. Okay, and this is the common ratio. Take a term and divide it by the one before it in that order. The common ratio R. Okay, so for example, suppose that I have this sequence 3, 6, 12, 24, 48. Okay, if I want to find the common ratio, I can pick any two terms, consecutive terms. So if I look at these two, and I would go ahead and take those two and divide. If I get a integer, great. 6 divided by 3 is 2. If I pick these two, I would do 12 divided by 6, and I get 2. If I decide to do these two, 24 and 12, then I would do 24 divided by 12. And again, it's not necessarily the larger number divided by the smaller number. It's not like that. It just happens to be that way here. It's always whichever term you choose, you divide by the 1 before it. Okay? And here we get 2, and then 48 divided by 24. Again, you get 2. So it doesn't matter which 2 consecutive terms you pick in the sequence, whether you pick these two, or these two, or these two. It doesn't matter which 2 consecutive ones. The ratio between them will always be 2. Okay, so this value here would be our common ratio, R. Okay. Let's take a look at this example here. Suppose that I have 2, negative 10, 50, negative 250, 1,250. Okay, and suppose that this is geometric and you are asked to find the common ratio. So in order to find it, you just pick any 2 that you want. If you want to pick the first 2, that's fine. If you want to pick these 2, that's fine. Or these 2, or these 2. Doesn't matter. You'll get the same thing if it's geometric. All right, so I'm just going to go ahead and choose the first 2, 2 and negative 10. Negative 10 has to go first, and then 2. So my common ratio is negative 5. If you're not sure, you can always check. 50 divided by negative 10 is negative 5. Okay, and so on. All right, let's take a look at the nth term of geometric sequences. Nth term of geometric sequences. Okay, so again, that would be this. AN equals A. A represents the first term. R to the n minus 1. Okay, so let's take a look at an easy example. Find the nth term. Find the nth term of the geometric sequence three, 6, 12, 24, 48. Okay, so let me not scroll that far up. Okay, so the nth term is this thing, this formula. Okay, so find the nth term. It's like finding this formula. In order to create this full formula, we need our first term and we need R. Okay, so we need our first term and we need R. Okay, let's write that down. Need A and R. Okay, all right, so what do we know? We know A. We know A is 3. R I can find. R is 6 divided by 3, which is 2. Okay, all right. So if I have those 2 pieces of information, then I can write my nth term. My nth term, AN, that's my nth term, is A, which is 3, times R, which is 2, to the n minus 1. Okay, so there's your nth term. And with that, now I can find any term. I can find the 5th term. I can find the 100th term. Okay. All right, let's take a look at this next one. Find the nth term of the geometric sequence 1, 1/3, 1/9, 1/27, 1/81. All right, so again, we need A. A is 1. We need R. R is, I can find it, 1/3 divided by 1. So R is 1/3. Okay, so again, now that I have both A and R, I can write my AN formula, my nth term formula. AN is first term, which is 1, times R, which is 1/3, raised to the n minus 1. Okay, so make sure you keep all of R in parentheses because all of R, 1 and the 3, get raised to n minus 1. Okay, if you don't put parentheses around 1/3, then only the 1 will be getting the exponent, not the 3. Okay, 1/3, R is all of this, which is 1/3. So all of this should get the exponent. Okay. You can write it like this. You can write it without the 1. Not really sure how WebAssign will accept it. So just if it doesn't accept this, then take off the 1. Okay. All right, finding terms of a geometric sequence. Finding terms of a geometric All right, let's take a look at this one. So I'm going to do 2 examples of this. Okay, the first one is relatively easy, and the second one requires quite a bit of work, sort of like the ones in the arithmetic ones. I'll show you a different method here, and maybe it'll be more helpful. Okay, so start off with this relatively easy one. Okay, so find the 8th term. Find the 8th term of the geometric sequence. Five, 15, 45, 135. Okay. All right, so in order to find any term, we need that AN formula, that nth term formula. In order to find that AN formula, we need the first term and we need R. Okay, so these are what we need. A, which is 5, R, which is 15 divided by 5, and that would be 3. And so our nth formula, or nth term, is 5 times 3 to the n minus 1. Okay, so this is given, this is found, and this is derived. Okay, so now I can find, when you have your nth term formula, then you can find any term they want. They want you to find the 8th term. All right, so in order for me to find the 8th term, I'm going to substitute 8 for n, and I get 5 times 3 to the 7th. And when I multiply that all out, I get 10,935. Okay, excellent. Okay, so this one is the relatively easy situation. All right, let's take a look at this next one. This next one is going to require more paper. Okay. All right, so the third term of a geometric sequence is 63 over 4. Don't be scared. Okay. The sixth term is 1,701 over 32. Find the fifth term. All right, so not as straightforward. This one requires you to really think about what you have. Okay, so what do we know? We know A1. We know A. Actually, we don't know A. We know A3. We know A3 is 63 over 4. We know A6 is 1,701 over 32. All right. So we don't have our first term. We don't have R. Okay. So what we're going to do is we're going to create a system of equations. Okay. So from this one over here, our first equation. Okay, so our first equation, we know that A3 equals whatever our A is times whatever our R is to the 3 minus 1, right? We do know what A3 is. A3 is 63 over 4. So I'm going to replace this A3 with 63 over 4. 63 over 4 is equal to A times R to the 3 minus 1 is 2. So I'm going to simplify that part as well. Okay, so we have our first equation. I am going to do the same thing here to get my second equation because we're trying to create a system of equations, system of two equations. Okay, so my second equation, I know that A6 is A, whatever A is, times R, whatever R is, to the 6 minus 1. Okay, and just like up here, I know what A6 is. A6 is this fraction over here, so I'm going to replace A6 with this fraction. So 1,701 over 32 equals A times R to the simplifying 6 minus 1. I have that. Okay, so now I have my two equations. So now I have my system of equation. My first equation is 63 over 4 equals A times R squared. And my second equation is 1,701 over 32 equals A times R5. And if you remember how to solve systems of equations, you can use elimination method. You can use substitution method. I'm going to go ahead and use substitution method. Okay, I have two variables. I have the variable A and I have the variable R. Okay, so I'm going to go ahead and take this first one and I'm going to rewrite it by solving for A. So I'm going to divide both sides by r squared, right? So I get 63 over 4r squared equals a. Okay. So all I did was rewrite that first equation, solved for a. Now I'm going to take this, a equals this. So then now I'm going to substitute that fraction over here for a. Then substitute into equation number 2. All right, so 1,701 over 32 equals a, but a is this, 63 over 4r squared times r5. Okay. Some r's will cancel out. 2 of these will cancel out with 2 of these, leaving me with 3, r3. So 1,701 over 32 equals 63 over 4 times r cubed. All right, you with me? All right, let's get the r cubed by itself. Okay, so we need to solve for r. So let's get the r cubed by itself. So I'm going to go ahead and multiply by the reciprocal, 4 over 63. That way they cancel, and that way they cancel. But what I do to one side, I have to do to the other. Okay. And then it turns out that this reduces to 27 over 8 equals r cubed. And now I have to take the cube root of both sides. So if I take the cube root over here and the cube root over here, these will undo each other. And now cube root of 27 is 3, cube root of 8 is 2. So r equals 3 over 2. And that is not my final answer. Okay. I need to now find a 1 or a. Okay. But up here, we said a equals 63 over 4r squared. So let's plug that in. A equals 63 over 4r, which is 3 over 2, squared. So we get 63 over 3. Oops, 63 over 9, actually. Because the 2 squared is 4, so it'll cancel out with this 4. So I'm only left with 3 squared, which is 9. And so a equals 7. All right, so a equals 7. So now I have my a, now I have my r, so then I can write my nth term formula. So an equals a times r to the n minus 1. Okay. So now that I have my nth term formula, I can find what they're asking me to find. What are they asking me to find? Find the 5th term. Okay, so find the 5th term. So I can use this to find the 5th term. So a5 equals 7 times 3 over 2 to the 5 minus 1. And that is just 7 times 3 over 2 to the 4th. And if I work this out, I get 567 over 16. So there you have it. The fifth term is 567 over 16. Okay. All right. So that does it for arithmetic sequences. Again, part 2 will deal with partial sums and infinite sums. So stay tuned.